All right, so I went ahead while I was doing it. I went ahead and did all the differences, found the residuals, and then just went ahead and squared those residuals to get that last column there. So knock on wood, hopefully I didn't mess anything up or anything like that. So check your work. Hopefully you were doing that on your own as you went along. So now the goal is we want to sum all these residuals together. So we just want to add up this last column. So we want 1193.7 plus 292.75 plus 242.42 plus 41.34 plus 371, oops, 0.72 plus 85.56 plus 8.35 plus 2.56 plus 108.78 plus 76.91 plus 0.59 gives us 24.68. So now we want to use our square root formula, our square root formula, or not square root formula, our standard deviation formula, which is to just take the square root of that number, 4.68, divided by our degrees of freedom. So in this case, I think there's 11 data points. So we got 1, 2, 3, 4, 5, 6, 7, 8, 10, 11. So our n is 11. So our degrees of freedom are going to be 9. So let's throw this in the calculator and see what we get for a standard deviation of the residuals. So let's see, divided by 9 equals that, and then square root of 2424.68 divided by 9 gives me, looks like 16.41 in this case for my standard deviation. And so again, remember, we're looking for 2 standard deviations, so we actually want to multiply this by 2s. So that gives us times 2, gives us 32.8283 or so. So that's kind of the magic number that we're looking for in this case. So we're looking for a value that's either bigger than 32.83 or smaller than negative 32.83 in this case. So these are the areas we're looking for. So either 32.83 or smaller than negative 32.83. All right, so in this case, using the standard deviation, identify if there are any outliers. So again, we've done all the hard work. So now what we're looking for is we're just looking at the residuals column. So we want to look at this column here. And we want to see if there's any residuals that are bigger than that 32.83 or smaller than negative 32.83. And so it turns out the very first one on our list is actually 34.55, which is bigger than the 32.83. So that very first point, 65, 175, is an outlier. So let's write it down. And then see if there's any other ones. So negative 17, that one's okay. 15, negative 6, negative 19, 9, 2, negative 1. So the rest of them all look good. So it looks like there's only one outlier in this set of data in this case. All right, so again, the worst part of this is just calculating the standard deviation. So just take your time. Try not to rush it so that way you don't hopefully make any mistakes or anything like that. Use your calculator to fill out that y-hat table, and then just be careful doing the rest of it. So finally, let's move on here to how does this outlier affect the regression line? Well, I mean, remember if it's a point that's not supposed to be there. So remember, an outlier could come from a lot of different things. So it could be that there was an error in calculating the data. So it could be that one of these exam scores was just totally wrong. Either the 65 was wrong or the 175 was wrong, and someone just wrote it down in error. Could be that, we just don't need it. Maybe it was like, who knows? But that's kind of what you're looking for. And so you have to be careful when you're talking about, what to do with these outliers, because you don't want to just throw it away if it's an important outlier. So what you want to do is you want to decide whether it can be thrown away. So for us, since we want to like see what happens if you get rid of it, we're going to assume it's an error and we don't need it anymore, and so we're just going to throw it out of the data. So in this case, what we're going to do is calculate a brand new regression line in R value based on the one less data point. So in this case, now we've only got 10 scores instead of 11 like we had before. And so again, this is going to be another kind of monotonous thing to go through because we're going through and kind of calculate all the different residuals and stuff like that. So we've done this before. This isn't anything new or anything like that. I just wanted to kind of show you what the R value looked like and then compare the two linear equations and stuff like that. All right, so let's dive in. So this kind of takes us back to what we were working on originally. So notice in this case, I've deleted that 65, 175 off of my list. So now my list starts with 67, 133, 71, 185. And so I've already taken the time to calculate the end's just counting them up. So 10, I calculated the mean to be 69.6, the standard deviation for X to be 2.63, the Y hat to be 159, and then the SY to be 21.328. And so again, what we're doing is we're calculating this first chart is just taking this 67 minus the 69.6, and we want to do this for every single value the whole way down throughout. So in this case, we're going to get negative 2.6, 1.4. So I'm not going to show you how to do these because they're just subtraction, and so that way, again, I don't want to bore you to tears. So 1.4 again, negative 3.6, 5.4, negative 2.6, 0.4, 1.4, negative 0.6, and then negative 0.6 again. So now we want to do the same thing for the y. We want to take this y minus the y mean. So we're going to do like 133 minus 159 for the very first position. So in this case, that gives us negative 26. And then do 185 minus 159. That gives us positive 26. So again, just keep subtracting these guys. I'm just going to write them down since it's nothing too hard, just tedious. So 4, so 0, negative 8, and 0. So now the next column, what we're going to do is take this column here and divide it by the 2.63. So in this first situation, we're going to take negative 2.6 divided by 2.63, and that gives us negative 0.987. And then we do the same thing. We're going to take the 1.4 divided by the 2.63 to get 0.531. And again, just keep doing this the whole way out. Just take this number, divide it by the sample standard deviation for X. So I'm just going to copy all these down so that way it speeds it up a little bit. But if you do have questions or if you run into trouble, let me know. So 2.051, negative 0.987, 0.152, 0.532, negative 0.228, negative 0.228. All right. So now, same thing. We want to take the residuals for y and divide them by the standard deviation of y. So in this case, we'd get negative 26 divided by 21.328. And that's going to be our first position here. Or not 26, negative 2. Oh, yeah, negative 26. I always looked at the wrong column. Yeah, don't make a mistake early on. It just snowballs and gets worse from there. So this would be negative 1.219. Then the next one, we've got another 26. So, but this time it's positive. So divided by 21.328. So that's just going to give us the positive version of this. And then we'll do 4 divided by 21.32, which is going to give us 0.188. And then negative 1.547. 1.829, negative 0.281, 0.188, big zero, those are easy to do, negative 0.375, and another nice zero there. It makes life easy. So now the last column, remember, that's just taking this guy and multiplying them together. And so again, just multiply negative 0.987 times negative 1.219. So negative 0.987 times negative 1.219, and that's going to give us 1.204. And then multiply 0.531 times 1.219. And so in this case, we get 0.648. So again, continue that multiplication. So we get 0.100, 2.115, 3.750, 0.278, 0.028. These zeros, the nice thing is multiplying by 0 just cancels those guys out. 0.085. And then we get another 0. So finally, what we want to do is sum that whole column together. So again, just throw it into your calculator. And so I'll just do it again just to make sure. So make sure I got the right answer. So 1.204 plus 0.648 plus 0.100 plus 2.115 plus 3.75 plus 0.278 plus 0.28 plus, I can skip the zeros, 0.085. So it looks like I ended up with 8.208 in this case. So 8.208. Perfect. So we're not quite done. So remember, to find our R value, we still need to divide by the n minus 1 in this case. So in this case, our R is going to be 8.208. We knew our n was 10, so we're going to divide this by 9. So dividing this by 9, we get our R value is, oops. So our R is 0.912 in this case. So if you remember, our original correlation coefficient for this problem was 0.663. So you can see what a major difference that one outlier caused to this data. So because if we did a hypothesis test on this, more than likely this wouldn't be significant. So even though we could use it as a way to estimate, it's not going to be a very good estimation. 0.663 is kind of in my area like the weak positive range, where the 0.912 that we just calculated is in the really strong positive range. So that's pretty impressive. So totally different, but nice. All right, so finally, let's calculate what the linear regression line, new linear regression line looks like. So again, we're going to take our A, which is going to be the 0.912, times our standard deviation of Y first, so 21.328, divided by our standard deviation of X, so 2.63. And so when I plug this in the calculator, what do I get here? It's 0.912 times 21.328 divided by 2.63 gives me an A value of 7.4 in this case, 7.40. And then our B, we're going to do our Y mean, which was 159. Minus our A we just found, which was 7.4, times our X mean, 69.6. So again, throw this in the calculator, so we get 159 minus 7.4 times 69.6 gives us a B value of negative 356.04. So our new regression equation is going to be y hat equals 7.4x minus 356.04. And so again, just to look at what a difference the slopes and everything made. So our original one was a 4.83 slope and a negative 173.5. And now we're looking at a 7.4 slope with a y-intercept of negative 356.04. And again, since this R value is so high, we know this is going to end up making a strong linear relation. Now we should run the hypothesis test on it and all that good stuff, but I figure we've done enough work for today, even for the semester. So for you guys, I'm going to have you guys go through the one problem. The bear problem ended up being not having any outliers either. So I gave you just practice one, or just the paper thrown away, because that one does have an outlier. And I took it easy on you. I just made you one practice problem. So kind of go through, do the same steps I did with mine. And good luck. So good job, everybody. Nice job all semester. I'm very proud of how hard you guys worked. I'll be around all day if you have any questions or anything like that, but nicely done.